The universe is a vast and intricate dance. Stars swirl in galaxies, planets orbit stars. This cosmic choreography is a testament to the grandeur and complexity of the cosmos. Each celestial body moves with a purpose, following paths laid out by the invisible forces that govern the universe. What invisible force orchestrates this cosmic ballet? What unseen hand guides the stars and planets in their eternal waltz through the void? It is the silent conductor of the cosmos, gravity. This fundamental force, though invisible to the naked eye, exerts its influence across the vast expanse of space, shaping the very fabric of reality. Gravity holds our solar system together, keeping Earth in its orbit around the sun. Without gravity, the planets would drift aimlessly into the void, and the delicate balance that sustains life on Earth would be lost. It dictates the structure of galaxies, drawing matter together over billions of years. The majestic spiral arms of galaxies, the dense cores of star clusters, all owe their existence to the relentless pull of gravity. Even the graceful arc of a thrown ball here on Earth is governed by this fundamental force. From the smallest pebble to the largest star, gravity's influence is inescapable. But what if we could seize control of this fundamental force? What if humanity could harness the power of gravity, bending it to our will? What if we could manipulate gravity at will? Imagine the possibilities: floating cities, interstellar travel, and technologies beyond our wildest dreams. The very thought sends ripples of possibility through the fabric of our imagination. The ability to control gravity would revolutionize our understanding of physics and open up new frontiers of exploration and innovation. It is a tantalizing dream, one that has captivated scientists and science fiction writers alike. From the pages of novels to the halls of academia, the quest to understand and control gravity has inspired countless minds. The ability to control gravity would be nothing short of revolutionary, ushering in an era of unprecedented technological advancement and fundamentally altering our understanding of the universe. Imagine a world where gravity is no longer a constant, but a variable we can adjust at will. The implications for transportation, construction, and even daily life would be profound. We could build structures that defy traditional architectural limits, create transportation systems that make current methods obsolete, and explore the farthest reaches of space with ease. The dream of controlling gravity is not just a flight of fancy, it is a vision of a future where humanity has unlocked one of the universe's deepest secrets. As we continue to explore and understand the cosmos, who knows what other wonders we might uncover? The silent conductor of the universe, gravity, may one day be an instrument we can play, creating a symphony of possibilities that stretches across the stars. Our journey to unravel the secrets of gravity begins with Sir Isaac Newton. Born in 1643, Newton was a mathematician, physicist, and astronomer who laid the groundwork for classical mechanics. His contributions to science are monumental, and his work on gravity is perhaps his most famous achievement. His law of universal gravitation, formulated in the 17th century, describes gravity as a force of attraction between any two objects with mass. This groundbreaking idea was published in his seminal work, Philosophiae Naturalis Principia Mathematica, often referred to simply as the Principia. In it, Newton articulated the principles of motion and universal gravitation, which became the cornerstone of physics for centuries. The more massive the objects, the stronger the gravitational pull between them. Newton's law of gravitation can be expressed with the equation F equals sine gm2 r squared, where F is the force of gravity, g is the gravitational constant, m1 and m2 are the masses of the objects, and r is the distance between their centers. This equation not only explained the motion of celestial bodies but also had practical applications on Earth. Newton's elegant equations accurately predict the motion of planets and the fall of apples from trees. The story of the apple falling from a tree, which supposedly inspired Newton's thoughts on gravity, has become a legendary anecdote. Whether or not the story is true, it symbolizes the simplicity and universality of Newton's laws. His work provided a framework that could explain both the orbits of planets and the everyday phenomena we observe on Earth. Centuries later, Albert Einstein revolutionized our understanding of gravity with his theory of general relativity. Born in 1879, Einstein was a theoretical physicist whose work changed the course of modern science. His theory of general relativity, published in 1915, offered a new perspective on gravity that challenged Newton's long-standing ideas. Einstein proposed that gravity is not a force at all but rather a curvature in the fabric of space-time caused by the presence of mass and energy. This was a radical departure from Newton's concept of gravity as a force. According to Einstein, massive objects like stars and planets warp the space-time around them, and this curvature directs the motion of other objects, much like a marble rolling along a curved surface. Imagine a bowling ball placed on a trampoline causing the fabric to sag. This analogy helps us visualize how massive objects distort space-time. The greater the mass, the more pronounced the curvature. Smaller objects moving nearby will follow paths determined by this curvature, which we perceive as the gravitational pull. This is analogous to how massive objects warp space-time, creating what we perceive as gravity. Einstein's theory has been confirmed by numerous experiments and observations, such as the bending of light around massive objects and the precise orbit of Mercury. These phenomena couldn't be fully explained by Newtonian physics but fit perfectly within the framework of general relativity. Einstein's insights have paved the way for modern astrophysics and cosmology, deepening our understanding of the universe. Controlling gravity, however, remains a formidable challenge. While we have made great strides in understanding this fundamental force, manipulating it directly remains firmly in the realm of science fiction. One theoretical approach involves the elusive graviton, a hypothetical elementary particle that mediates the gravitational force. If we could harness gravitons, we might be able to control gravity. Another avenue of exploration lies in the realm of exotic matter, such as negative mass. Unlike ordinary matter, which has positive mass and attracts other matter through gravity, negative mass would theoretically repel other matter. If we could create and control negative mass, it could potentially lead to breakthroughs in gravity control. Imagine a future where spacecraft effortlessly glide through space, freed from the constraints of chemical rockets. No longer would we be bound by the limitations of traditional propulsion methods that rely on explosive fuel and complex engineering. Instead, we would harness the power of advanced technologies that allow for smooth, continuous travel through the cosmos. With gravity control, we could manipulate the fabric of space-time itself, bending and shaping it to our will. This would enable us to create warp drives, a concept once relegated to the realm of science fiction, now becoming a tangible reality. These warp drives would propel us across vast interstellar distances faster than the speed of light, making journeys that once took decades or even centuries achievable within a human lifetime. Imagine traveling to distant star systems, exploring new worlds, and discovering the mysteries of the universe firsthand. Space travel would no longer be a distant dream, but a tangible reality, accessible to scientists, explorers, and even ordinary citizens. The barriers that once confined us to our own solar system would be shattered, opening up the cosmos to human exploration and colonization. This new era of space travel would see humans setting foot on new planets, establishing colonies and expanding our presence beyond Earth. We would become a multi-planetary species, ensuring the survival and growth of humanity for generations to come. Gravity control could also revolutionize our approach to space exploration within our own solar system. We could travel to the outer planets with ease, conduct in-depth studies of their moons, and even explore the icy bodies of the Kuiper Belt. We could establish permanent bases on the Moon and Mars, creating self-sustaining habitats that support human life. These bases would serve as stepping stones for further exploration, providing a launch pad for missions to more distant destinations. Shielded from harmful radiation by artificial gravity fields, these bases would offer a safe environment for astronauts and researchers. The technology would protect them from the harsh conditions of space, allowing for longer missions and more extensive research. Asteroid mining would become a viable industry, opening up new economic opportunities and providing us with valuable resources. We could extract metals, water, and other materials from these celestial bodies, reducing our reliance on Earth's dwindling reserves. This would not only support our space endeavors but also benefit industries on Earth, driving technological advancements and economic growth. The resources obtained from asteroids could be used to build new spacecraft, develop advanced technologies, and support the growing space economy. In addition to mining, we could construct massive space stations and orbital habitats, creating new living spaces for humans. These structures would be equipped with artificial gravity, sustainable life support systems, and all the amenities needed for long-term habitation. Space tourism would flourish, allowing civilians to experience the wonders of space firsthand. Imagine taking a vacation to an orbital hotel, enjoying breathtaking views of Earth from space. and experiencing the thrill of zero gravity. This new era of space travel would also foster international collaboration, bringing together the brightest minds from around the world to work on common goals. Together, we could tackle the challenges of space exploration, share knowledge, and achieve feats that no single nation could accomplish alone. The future of humanity in space is bright, filled with endless possibilities and opportunities. As we continue to push the boundaries of what is possible, we move closer to becoming a true spacefaring civilization, exploring the cosmos and securing our place among the stars.